Alright, in this video we're starting 8.6. We're going to be solving rational equations. We have here cross multiplying. I've been thinking about whether to show you that or just keep it the same method on all problems. So I decided I'm not going to show you cross multiplying. Alright, I'm going to keep it, I'm going to use the same method for all playlists of 8.6 videos. Alright. So when solving rational equations, well, there's an equals, that's the reason why we're solving, and that's why it's called an equation. The first thing you want to do is you want to factor the denominators completely. All right, so this one's completely, this one I can factor out of 2. All right. So what I'm going to do is, see, I cannot solve this until all the x's are out of the denominators. Okay, so that means I have to get rid of the denominators. So in order to get rid of the denominators, you have to multiply by the common denominator. And my common denominator in this case is x minus 2, a 2, and the x minus 5. So that means if I take this right here and multiply both sides by that, I should eliminate both denominators. Okay? Now the reason why I multiply both sides is because of the equality. What I do to one side, I must do exactly to the other side. Alright? So I'm going to go ahead, I'm going to take 7 over x minus 2 equals 11 over 2x minus 10. Alright, let me zoom in a little bit more. Okay. What I'm going to do now, as I said before, I'm going to put 2x minus 10. I want it factored. Leave it as this. Okay, 2x minus 5. I'm going to multiply both sides by that. So I'm going to write this over here. And I'm going to write it over here. The order that I put these in doesn't matter. I can go 2, x minus 2, x minus 5. I can go x minus 5, x minus 2, and 2. Order is not important. As long as you're multiplying both sides by the exact same thing, you're good. Alright, so the next step is now I'm going to multiply. So really this is over 1. Well, that goes right back. I have something the same up top as something on the bottom, so I can cancel that. That's what all of 8.5 was all about. So now I have left is a 2, x minus 5, and a 7. And remember, we're multiplying. All that is up to, is what I have left over. There's nothing left over on the bottom. Alright, here, so the 2's cancel, and the x minus 5's cancel, so I'm left with the x minus 2. So I have 11 and an x minus 2. Right? The fractions are gone. So all I have to do now is multiply everything out and then begin solving. Alright, so 7 times 2 is 14. Multiply 14 through, so it'll be 14x minus 14 times 5 is 70 equals 11x minus 22. All right, so this is linear, so that means we want to get the variable by itself. So I'm going to subtract 11x. So I get, let's see here, 3x minus 70 equals negative 22. Let me rewrite it up here. 3x minus 70 equals negative 22. Add 70 to both sides. So I get 3x is equal to, well, 70 minus 22 gives me 48.
Dr. McCann, could you report to the maintenance room, please? Dr. McCann, report to the maintenance room. Thank you.
All right. You get that? All right. Report to the maintenance room. Now back to the problem. All right, so now I'm going to divide both sides by 3. So therefore, let's see, 48 divided by 3 is what, 16? All right, so there's my answer. Now what I have to do now is I got to check for extraneous solutions, if I can say that right. What that means is, since I have a variable in the denominator, that means what values I give for x, I have to check it because I cannot have the denominator going to 0, because you cannot have a 0 in the denominator. And since I have variables there, I gotta check to make sure that I do not get a 0. So I'm gonna take 16, which is my only solution. So 16 minus 2 is 14. So that works on that side. 16 times 2, which is 32, minus 10 is 22. So I did not get 0 on either side. So therefore, this is a solution. And I don't have to worry about that. There's no extraneous solutions. All right. Let's look at another example. Same thing. All right, so here and here, they're already factored, or those can be factored. So my common denominator is 5x and x minus 7. So that's what I'm going to do. I'm going to multiply both sides by that. So I'm going to multiply both sides by 5x and x minus 7. All right. So on this side, so if I cover this, remember this is over 1. So the 5x is canceled. So I'm left with 3 times x minus 7. So I'm left with 3 times x minus 7, or x minus 7 times 3, doesn't matter. On this side, those cancel. So I'm left with 5x times 2.
Security desk, Alicia Malatesta.
Right. So now multiply everything out. So I get 3x minus 21 equals 10x. I'm going to subtract 3x. So I get negative 21 equals 7x. Divide both sides by 7. So x is equal to negative 3. Now I look back at my original equation. I noticed that there was variables in my denominator. So that means I have to check the solution to make sure if it works or not. So I'm plugging negative 3. So negative 3 times 5 is a negative 15. So that's not 0. So it works on that side. Now come over here. Negative 3 minus 7 is negative 10, which is not 0. So it works on that side. Since this works on both sides, therefore that is my answer. And that means I do not have any extraneous solutions. All right. Hopefully we'll get to one that you'll see what I mean. All right, last example. Again, these are already factored. So my common denominator will be x plus 3 and x minus 3. I write that on both sides. Oh, 3, not 5. All right, and remember this is over 1 now. So our goal is for these to cancel. Well, it does. So I'm left with negative 4 and an x minus 3. Here, those cancel out, so I'm left with a 5 and an x plus 3. Multiply it out. Distribute here. I get the variables on the same side, so I'm going to add 4x. That gives me 9x. Subtract 15 from both sides. That gives me negative 3 equals 9x. And then divide both sides by 9. So negative 3/9 equals x. Simplify it. Negative 1/3. All right, so negative 1/3. Again, I have variables in my denominator, so I got to check. Negative 1/3 plus 3, will that give me a 0? No. Negative 1/3 minus 3, will that give me a 0? No. So therefore, this is a solution. All right, that ends the first playlist.